Hello everyone. In last lecture, we have studied the site clearance, job layout, then different methods of carrying out the job layout, that is central line method and the face line method, then precautions to be taken while laying the job layout and the excavation for foundation. So, in today's lecture, we will study the next topic, that is timbering and strutting. So, while carrying out the excavation work, we need to do the earthwork for excavation. So while carrying out excavating the trenches, sometimes the soil of the sides of the excavation trenches start falling down. When it is soft soil, then it become difficult for the worker to carry out the excavation work. So in order to prevent that, we need to provide some temporary support on the sides of the excavation trenches so that we can avoid the falling of the soil from the sides into the excavation trench. So it become easy for the worker to carry out the uh, excavation work in deep ground. So hence, when we provide the temporary support, the temporary support is called nothing but the timbering and strutting. So it is the method of giving the temporary support to the sides of the excavation trenches. So there are different methods of the timbering and strutting. So first one is the box sheeting, next stay bracing, runner system, vertical sheeting and the sheet piling. So we will study the first method, that is box sheeting. So in case of box sheeting, when the depth of our excavation is up to 4 meter and if the soil is loose, then in that case we use the box sheeting method. So in that box sheeting method, it consists of the vertical sheets which are held in position by the horizontal rows of wheels which are made tighten by the strut. So in case of box sheeting, the vertical sheets are placed on the sides of the excavation trenches and the vertical sheets are fixed with the help of that bells and the bells are fixed with the help of strut. So it is the box sheeting. So next it's the stay bracing. Next is the vertical sheeting. The vertical sheeting method is just like similar to the box sheeting method. Only difference is that in the case of vertical sheeting, the excavation is progressed in the stages by providing an offset at the end of each stage. So this method is best suited for the deep trenches in the soft ground. So in case of vertical sheeting, the excavation is carried out in the stages by providing the offsets. So the next method is the stay bracing. Now the stay bracing. When the depth of our excavation is up to 2 meter, then the bracing method is adopted to support the sides excavated in the fairly firm soil. So in case of the stay bracing, it consists of the polling boards opposite to another sides, and then it is connected by the vertical sheets with the help of struts. Here is the stay bracing. Here polling boards are placed opposite to each other and both the polling boards are connected with the help of the strut. Next is the runner system. So when our soil is extremely loose and it start falling down in the trenches immediately after the excavation is started, so in that case the runner system is used. So runners can be easily driven into the ground by the sharp iron shoe at the lower end of the runner. So when our soil is extremely loose, so in that case runner system is used. Next is the vertical sheeting. In case of the vertical sheeting, the excavation is progressed in the stages. Otherwise, it is similar to the box sheeting. So, next is our sheet piling. In this method, sheet piling is used under the following conditions: if our depth of excavation is more, if the subsoil water is there, if the width of trench is wide and large, and if soil is loose and soft. So under the following condition we uses the sheet piling for the timbering and the strutting. Now the next is different tools and plants are used for the earthwork. So there are different equipments which are used while carrying out the excavation work, dewatering work, timbering and strutting work. So first one is the spade, then fowler, pickaxe, crowbar, rammer, wedge, boning rod, sledgehammer, basket, iron pan, line and pins. Here are the different equipments which are used for the excavation work, dewatering work. Now next is the lead and lift in the excavation. So firstly the lead is the horizontal distance and the lift is the vertical distance. So standard lead distance taken is generally the 30 meter and lift distance taken is the 1.5 meter. So lead is the horizontal distance up to which a contractor with hole will hold the material excavated, and it is included in the rates of excavation is called as an lead. So lead is basically the horizontal distance where the excavated material will be dumped, and above that 30 meter the worker will charge the extra charges for dumping the material for the distance more than the lead distance. So next is the lift. Lift is the vertical distance up to which a contractor will haul the material excavated, and it is included in the rates of excavation is called as lift. So basically the lift is the vertical distance, and it is generally the 1.5 meter standard, and the lead is 30 meter. Now next topic is the foundation. Foundation is the most important part of the structure. So foundation is the lowermost part and it carries all over the load of the superstructure, and it transmits the load of the superstructure down into the soil safely and distribute the load all over the area of the soil. So foundation is the lower part of structure, and in addition to provide the base for the superstructure, it transmits the load of the structure to subsoil without any damage. Hence a strong foundation is necessary. So foundation transfer all over load of the superstructure to the soil. So there are different purposes of the foundation: to distribute the load of superstructure, then to provide the level surface for building operation or the construction operation, then to take the structure deep into the ground to provide the stability and prevent the overturning. In order to provide the stability to the structure, foundation is needed. Then to minimize the chances of unequal settlement by distributing the load over the wider area. Hence, in order to avoid the unequal settlement, we need to provide the proper foundation. Now next is the classification of the foundation. What are the types of foundation? So basically there are two types of foundation: shallow foundation and the deep foundation. We can say as the shallow foundation when the depth of the foundation is less than the width of the foundation. In that case it is known as shallow foundation, and when the depth is more than the width of foundation, then it is known as a deep foundation. So now the types of different classification of the shallow foundations are: wall footing, isolated footing, combined footing, cantilever footing, inverted arch footing, grillage footing, raft or mat footing. And next, deep foundation classification is the pile foundation and the well foundation. So these are various classification of the foundation. Now next are the requirements of the good foundation. So why we require the good foundation? In order to distribute the whole weight of the structure safely over the larger area of the soil, then to avoid the unequal settlement, in order to prevent the settlement, then to provide the level surface for the building, The foundation takes the structure deep into the ground, thus increases the stability. So in order to increase the stability of our building and to provide the overturning, then the foundation shall be constructed to sustain the dead and impose load and transmit them to the subsoil. It does not cause the settlement. There are various requirements. Next is the foundation structure should be stable and safe against the possible failure. So in case of any failure, it should be safe and stable. Next, foundation should be taken sufficiently deep to guard the building against the damage or distress caused by the swelling or shrinkage of the subsoil. So swelling and shrinkage basically is caused in the black cotton soil. So in order to avoid that, foundation should be taken deep into the ground. Next, foundation should be located that its performance may not be affected due to any unexpected future influence. Now next is the open foundation. So when the hard strata is easily available at the less depth or very shallow depth, or our work is unimportant like compound wall, then for wire fencing, so for that purpose we provide the open foundation. Open foundation is basically a layer of foundation concrete provided at the base of column, pedestal or the wall, or simply a layer of concrete provided. It is the open foundation. So next is the shallow foundation. So shallow foundation is the foundation when our depth of foundation is less than the width, so in that it is known as an shallow foundation. So there are some limitations of the shallow foundation, that is the load carrying capacity is considerably less as compared to deep foundation, so and cannot be used under marshy land made up of ground or waterlogged area. We cannot use the shallow foundation in the waterlogged area, and load carrying capacity of shallow foundation is less. So these two are limitations of the shallow foundation. Now next is the various types of shallow foundation. First is the wall footing. Now in case of wall footing is generally provided in case of a load bearing structure. It is constructed the stepwise. So firstly, the lean concrete bed, normally PCC, is spread over the entire length of wall, the minimum thickness of 15 cm and the projection on either side normally 10 to 15 cm. The PCC is provided, then it provides a uniform base on which actual construction of wall footing can be started. So firstly the PCC is provided, and then on that PCC the uh, wall footing is constructed. Now it can be constructed with the help of brick masonry or in the stone masonry. Next is the reinforced concrete footing. So whenever the load carrying capacity of the soil is less on which our wall footing is to be raised, and the load carried by that wall is more, so in that case we provide the reinforced concrete footing. Next is the column footing, in that isolated footing. So generally the isolated footing is provided under the column in order to distribute the load on the soil. So isolated footing may be of the square, rectangular or the circular in plan or shape. Then it may be constructed in the brick masonry, stone masonry or the RCC steel grillage. So here is the RCC column footing. Next is the combined footing. So combined footing is generally provided for two or more columns. It is provided when the columns are nearer to each other, or when the separate footing of that column overlap each other. So in that case the combined footing is provided. In this type of footing, the common PCC bed is provided on which two or more columns rest. A common PCC bed is provided. Then shear force calculation is important in the combined footing. Combined footing may have rectangular, square, or the trapezoidal shape. Rectangular and trapezoidal footings are most common. So combined footing is generally provided in, in order to when the columns are nearer to each other. Next is the raft foundation. When the bearing capacity of our soil is very low and the load transmitted is heavy, then in that case the raft foundation is provided. When there is a marshy land or land made up of ground of soft clay, then under that case the raft foundation is provided. Then it provides to be economical under the waterlogged area. In the area where there is waterlogging, then in that case it may be proved to be economical. Then the raft is acting as the floor consisting of the thick reinforced concrete slab covering the entire area of the bottom of the structure. The slab normally projects 30 to 40 cm on all sides of outer wall. The excavation is made to be required depth. The entire area is well compacted, and then when the surface is dry, then the slab is laid. So generally when the bearing capacity of our soil is low and the load transmitted is heavy, in that case raft foundation is used. Then in also when there is a waterlogged condition, in that case also the raft foundation is most suitable. Now next type of foundation is the deep foundation. When the depth of our foundation is more than the width, then in that case it is known as the deep foundation. So generally it is the when the depth of foundation is more than 2 meter, then it is also called as a deep foundation. Generally we provide the deep foundation in case when the hard strata is available at the very far depth, it is not available at the shallow depth, or when our the bearing capacity of our soil is very low. Likewise in case of the black cotton soil, as black cotton soil has very low bearing capacity and also it has the swelling and shrinkage problem, due to which there is a settlement of our structure. So in that case the deep foundation is provided in the black cotton soil. Then different types of deep foundation are pile, caissons, and the cofferdam. Then piles are divided into two types depending upon the function, depending upon the material. So first, depending upon the function, bearing piles, friction piles, sheet piles, anchor piles, batter piles, fender piles, and the compaction pile. Then depending upon the material, timber pile, concrete pile, and the steel piles. Now caissons are of two types: open caisson, box caisson, and another third type is the pneumatic caissons. Then cofferdams, earth-filled cofferdam, rock-filled cofferdam, and the sheet piles cofferdam. So first we will see the pile foundation. So pile foundation is the type of foundation that transfer the load to the deeper component of the soil. Then pile is used as the structure is situated on the seashore or riverbed, and if the top soil has poor bearing capacity, generally pile foundation is used in the black cotton soil. So pile foundation is used when there is inadequate bearing capacity of shallow foundation to prevent the uplift forces and to reduce the settlement. In these cases, under following cases, the pile foundation can be used. So next is the bearing piles. Bearing piles. So bearing piles are driven into the soil until reach the hard stratum. This rests on the hard stratum and transport the load of the structure through the soil to the hard stratum. These are used to carry the heavy load safely to the hard strata. Then next is the friction pile. So friction pile transfer the load to the soil due because of the friction between the pile and the soil. Mostly the load is driven by the friction. So when the soil is soft to considerable depth, the pile which required to be driven is called as an friction pile. Now next is the sheet piles. These are used to retain the soil which is liable to escape laterally when subjected to the pressure, or to enclose the area for some foundation and to protect the area from the flowing water. So sheet piles are used to retain the soil which is liable to escape down, or in case of water, so to protect the area from water, in that case the sheet piles are used. Next is the anchor piles. When the piles are used to provide the anchorage against the horizontal pull, then they are called as the anchor piles. Next is the batter piles. When the piles are driven at an inclination to resist the large horizontal or inclined forces, then they are batter piles. In order to resist the horizontal and inclined forces, the batter piles are used. Next is the fender piles. When the waterfront structure or concrete check is required to protect from the impact or abrasion caused by the ship, then the fender piles are used. Next is the compaction piles. When the piles are driven to increase the bearing capacity of the granular soil, then they are called as a compaction pile. In order to increase the bearing capacity, the compaction piles are used.